Hello all. Today we'll be solving the question which was asked in JEE Main 2018 Set A question number 3. So I've already discussed the concept of such type of questions in the last video. So what's the question here? So there are two objects of mass m1 5 kg, m2 10 kg are connected by an inextensible string over a frictionless pulley. The coefficient of friction is 0.15. Now you should remember the coefficient of friction all should be for this surface only because this object is hanging in air. So therefore we are considering the coefficient of friction for this horizontal surface. So the coefficient of friction is 0.15. The question asked here is minimum weight m that should be placed, minimum weight m that should be placed on object of mass m2 to stop this motion. And here we are given with the four options. So let's see. So in diagram they have already given that whatever we have discussed in the last video, that tension is always directed away from the object. So tension is directed away from the object T, and this is also T. And weight acts vertically downward, so m1 into g. So they have already mentioned this. So now let's solve. So the weight acting vertically downwards, m1g, tension away from the object T, one string, one tension, so this is also T, and away from the object direction. Now see this object, in which direction this object is going to move. Obviously this object will not move in backward direction. If it is moving, then it will move in forward direction. So if it is moving in forward direction, what will be the opposing force? That is the force of friction. Force of friction will be in opposite direction, Fs. Now the question asked is that minimum mass m required to stop the motion. So finally we have to stop the motion. That is, we can consider that the system has to be in equilibrium at the end. So if the system is in equilibrium, that is, if this object is not moving, if the motion is stopped, then upward force should be equal to downward force. So for mass m1, we got the upward force T should be equal to downward force m1g. Next, if you consider this one, again, if this motion has to be stopped, the forward force and the backward force should be equal. So that is T equal to Fs, where Fs is frictional force. So therefore, T equal to, the formula for frictional force is mu into n, where n is normal reaction. And this normal reaction, the formula for normal reaction is nothing but the weight. So here if you see, there are the total mass is m2 plus m. So in case of mass we'll write m2 plus m, and finally for weight we multiply with g. So what if anyone is confused here, I will again say that normal reaction is nothing but the weight of the object. Now for this horizontal position, now what is the total weight for this object? m2 plus m into gravitational acceleration g. So take this equation 1 and this as equation 2. Left hand side are same, so therefore right hand side should also be same. So m1g should be equal to mu into m2 plus m into g. They have already mentioned the values of m1 and m2. So if you see the value of m1 is 5. So this is 5 into G we are taking 9.8. You can also take it as 10 for easy calculation. Then mu 0.15. They have given this 0.15 coefficient of friction. M2 10 plus M into again here G. So G again, that is 9.8. You can cancel this G. So what's remaining now? That is 5 upon 0.15 equal to 10 plus M. So 5 upon 0.15. So that will become around 33.3 equal to 10 plus M. So this implies M should be 23.3 kgs. But if you see in the option, see, we have solved the question. If you see in the option, there is no value of 23.3. But what was the question? Minimum weight that we need. So we found the minimum weight is 23.3. Now from here, which will be the minimum weight which corresponds to this? That will be obviously 27.3 is the closest minimum. Okay. Below that, if we apply below this, then this object won't stop. So if we apply 27.3 kg here, the motion will stop. So the correct option is 27.3 kg. Okay. So if you have any queries related to this question, you can mail us to GATE JEE NEET Q&A @gmail.com. Thank you.